This is a 5-minute review of significant figures, and I'm Fred Oakes. Significant figures are digits that have a numerical value. You might say, don't all numbers have a numerical value? Not quite, we'll get to that. Significant figures are used for rounding after multiplication or division. We'll also talk about addition or subtraction at the end of this video. How many digits in a number are significant? Well, let's take an example of a gold block. Let's measure its mass and find out if it's 103.20 grams. Then let's measure how tall the gold block is. It's 0.0254 meters. Now if you look at the zeros for the mass, you see that the zeros for the mass mean a number. It's not 103.21 or 103.22, but it's 103.20. The zeros in there mean a numerical value. However, the zeros for the height don't mean a numerical value. They're placeholders. They just tell you we're talking about hundredths of a meter rather than tenths. So we treat them differently. The rules for significant figures are as follows. First, all non-zeros are significant. If it's not a zero, it's significant. So for example, in 12.4, all three of those are significant figures. Zeros in between non-zeros are also significant. So the zero in between the 5 and the 1 and the zero between the 1 and the 2 are all significant. So 5 sig figs for 501.02. Zeros to the left of non-zeros are not significant. So for example, 0.08 has only one significant figure. It's to the left of the 8, not to the left of the decimal point that we're talking about here. The final rule is the most complicated. Rules to the right of non-zeros are not significant unless there's a decimal point. So two examples, we have 60. 60 with no decimal point has only one sig fig, the 6. But 60 with a decimal point has 2 sig figs because of the decimal point. All right, let's do a couple of examples. 4,500. How many significant figures? Well, the zeros are to the right without a decimal point, so only the 4 and the 5 count for 2 sig figs. How about 7.30? How many significant figures? The 0 is to the right, but there's a decimal point, so it is included. 3 significant figures. How about this number with zeros to the left and zeros to the right? The zeros to the right count because of the decimal point. The zeros to the left never count. So 4 significant figures. And then finally, how about this scientific notation number? The 0 in between counts, and in fact, the zeros to the left are represented by the scientific notation, 10 to the negative 28. So those don't count. Only 4 significant figures in that number. All right, let's do a calculation with significant figures. When we multiply or divide, the answers can't have more significant figures than the data with the least sig figs. Or, perhaps more simply, round your answer to the least sig figs. So let's take that gold block and determine its density. We'll measure its mass, and for this case, it's 100 grams. We measure its volume with the Archimedes method or displacement method, and it's 5.18 milliliters. Put the numbers in place and calculate a value. You always do that even when you're rounding. The answer is 19.305019. Where do you round? To what number do you round? Well, the mass has just one sig fig. The volume has 3. So the answer can only have one significant figure. So take 19.30, round it to 1 sig fig, and the answer becomes 20. The correct answer is 20 grams per milliliter. Now let's look at addition and subtraction. Addition and subtraction is easier. When adding or subtracting, the answer can't have more decimal places than the data with the fewest decimal places. Or, round your answer to the fewest decimal places. Let me give another example. Let's take 2 liquids, which we'll add together. For the beaker on the left, we measure 58 milliliters. For the graduated cylinder on the right, we measure 26.2 milliliters. Add those two numbers together to get 84.2, and now deal with rounding. For addition and subtraction, keep the decimal places for the least of the data. In other words, it's 84 milliliters since 58 has no decimal places and 26.2 has 1. Okay, so let's quickly summarize. For multiplication and division, use significant figures and round to the least sig fig. However, for addition and subtraction, round to the fewest decimal places.